Okay, welcome to a very special showing of our the most significant research and news. One of the things is, we do this every Thursday at 12 noon, except with this being Thanksgiving, we're going to do a special Wednesday showing for Thursday. But I want to give you information that you're going to be able to use because we're going to really eliminate a few myths. Then we'll give you some additional information about Thanksgiving and about eating turkey and about the fact that, why do people get sleepy afterwards? And hey, how about this one? Why don't we eat turkey eggs? Why, Thanksgiving, you're going to have plenty of turkey, but will you have turkey eggs? And why is that? And do people eat turkey eggs? So let's just start off. And one of the things that I want to get into is and I welcome everybody for the most significant research and news. And today it's more just a timely news, I would say, and it's timely because of the fact that this is Thanksgiving. I am Dr. Ray Wisniewski, and I am the founder and CEO of Nutrimost Wellness and Weight Loss. So we're let me just see. Here we go. There I am, and you can actually find us and contact us at Nutrimost.com. That's Nutrimost.com. Or you can give us a call at 855-Nutrimost. That's 855-688-7466 for any information. But let's just go back and take a look. I just want to go through how this all works, just so you understand this. First of all, let's realize that there's the blood-brain barrier. And the blood-brain barrier is made up of, you have these, what's called the tight junction epithelial cells. And then you have these, the nerve cells, the astrocytes, have these feet that come down. The cell comes down, there's what's called the astrocyte end feet. And they sort of hold this blood barrier in basically to prevent materials from entering into the brain. It's a very tight barrier. And the amino acids are actually lined up to go into the brain. And one of those is tryptophan. And you'll hear tryptophan is always blamed for, that's why you eat turkey, and it's the tryptophan goes into the brain, and tryptophan becomes serotonin, and serotonin actually is what is used to produce melatonin, and melatonin is what controls these sleep cycles. So when we take a look at serotonin, we know that it does many different things. It's responsible for mood. It's also, tryptophan is responsible for many different things. It even makes some of the B vitamins like niacin, and helps digestion, helps your skin, helps the nerves. It's very calming. Serotonin is more calming for mood. It does help with sleep. Okay, so you'll hear, well, turkey is high in tryptophan, and that's why as the tryptophan enters the brain, you're going to have this issue. That's not what it is, at least not completely. Let's tell you the rest of the story, because here's what happens. Of all the amino acids, which tryptophan is, it's one of the least in numbers. So it competes for this transport system because there's a shared transport system that allows the tryptophan to cross into the blood-brain barrier. So now you have the other amino acids, which are a higher number in there. It's competing with those other amino acids. Well, since tryptophan is larger and it's less in numbers, it has a more difficult time crossing into the blood-brain barrier. But as you eat a Thanksgiving dinner, it's not the rise in the tryptophan as much as when you start to bring in the other carbohydrates. It increases the insulin. Now, insulin affects all the amino acids except for tryptophan. Well, it sort of does affect tryptophan, but in a different way. Let me explain. The other amino acids, the rise in insulin helps drive those amino acids into the skeletal muscles, especially the branch chain amino acids. I'm talking about L-leucine, L-isoleucine, and L-valine. Okay, so those ones in particular are being driven into the skeletal muscles, but not tryptophan. So now as you have much higher concentration, much higher proportion of tryptophan at the blood-brain barrier, it seems like it would be able to rush across the blood-brain barrier easily. But the insulin does something else. It causes a greater portion of the tryptophan than would normally happen to be bound to albumin. And so now you have free tryptophan and you have bound tryptophan to the albumin. So you have one aspect of the insulin is going to cause a much greater increase in tryptophan into the brain, but the other causes it to have less of an impact. So now you have two competing systems here. So what is the net result? Well, the net result is that you have a slight increase in tryptophan into the brain. And that it's really amazing how the body is actually balanced. Think about this. Because if you didn't have it, if it wasn't binding then to the albumin, then it would be much higher. And it's really this combination between serotonin and dopamine. And you have one amino acid, which is tyrosine, helps make the dopamine. It's necessary for dopamine. And dopamine helps improve attention. Dopamine gives you drive. Dopamine is the reward and happiness neurotransmitter. So now you actually have less dopamine. You have more of the tryptophan. So that's another thing. It's that balance that happens with that. Now the other thing that happens is during Thanksgiving is we tend to overeat. To eat, that requires energy, and particularly it requires energy, requires even more energy. It's called TEF. That's a whole other thing, but I talked about that on an earlier presentation. But one of the things is that that increase in production, in other words, it takes energy. And then if you add alcohol into that, alcohol is going to cause sleepiness as well. So now you have this almost this trifecta, even more than that, because now you have increases in tryptophan into the brain, you have decreases in dopamine, you have increase in the amount of food you have digestion, and your body's working, and you're activating these receptor sites that are going to promote sleep. You're going to have more melatonin, and you add alcohol to that, and that's when the things you get. Now, I want to go over one other thing, because if we look at, let me just take this. Let me just go through here. I'm going to show you. This is some genetic polymorphisms. Oh, I didn't take it over. Sorry. And you can see if it's a COMT, if it's either if you have a homozygous polymorphism or even a heterozygous polymorphism, it's going to need more tryptophan and less tyrosine. So those people are actually going to do better. In fact, by the way, almost all the time, as far as people ask me, what if you have too much tryptophan? Well, first of all, if you're taking the tryptophan in the form of a supplement, it can cause neurodegeneration. In fact, years ago there was a big thing. I can't remember. I want to say it was from Japan. It was either Japan or China. It was a high amounts of, there was tainted tryptophan. And you had a lot of people using tryptophan for a lot of different things. And it caused all kinds of problems where people, I don't know if people, like some people died, I believe, from that. A lot of people were near death. And it was basically banned. It wasn't the tryptophan was banned, it was banned from where it came from. But because of that, you saw it sort of disappeared, because it was in favor for years back. It was a supplement that a lot of people took, but then they stopped taking it because of that happened. And you see it doesn't really come back. But the fact is, if you take it as just as a pure supplement, you have to watch out for that. It can cause some neurodegeneration. If you have it in your food, you know, it's totally different when it comes from the food, totally different. If in the food, very, very difficult to overdo tryptophan for any reason. and it's really controlled. If it wasn't for the increase in the carbohydrates, if it wasn't for the increase in the insulin, the carbohydrates stimulating the insulin, it really wouldn't even have much of an effect, just because of the fact that there's tryptophan, for instance, like in turkey, but there's also tyrosine. There's also all the other amino acids. That's what makes up those proteins. And tryptophan is one of the least in number on that. But as we get into, so you don't really have to worry about these genetic polymorphisms. What I was just showing you is that there's certain, like if you have a, and when we put this, by the way, when we use this with our Nutrimost intelligence and the food plan intelligence and the supplement intelligence, one of the things that happens is that we look, and for instance, if someone had both, if it was a, there's no polymorphisms for COMT or VDR TAC, that basically these people are going to actually have usually a greater toxic load, and it is more difficult. It's going to take a little longer to heal on some of those individuals. We would both increase both tyrosine and tryptophan. But what I put on here, and the reason why I added that, is that our program is designed to take a look at things and say, okay, well, if that's the case, if you come up with this biochemical profile, then once you come up with the profile, then that allows you to determine, okay, what are the foods that are going to best match that? How can I best help that? And those are some of the things that we can do. One of the other things I want to show you, and this is pretty cool. I'll just give you some information. This is some genetic testing was done. A lot of people don't realize that our domestic turkeys come originally from the wild turkeys in South Mexico, and this study was really interesting. It's back in 2012, BMC Genomics, and what they showed was that they showed that they got, well, this was pretty startling. They had almost some perfectly preserved DNA from wild turkeys from 1899 from southern Mexico. And they showed that, number one, our turkeys are all from those, but they also showed that the way that they were bred, that they created genetic gene variants that resulted in larger breast meat. They have much more meat, much more flesh to them. But they also showed that not only do they have much more meat and flesh, but there's much less variation within the actual turkey itself. So that was pretty interesting. That most other livestock, this is the effect of insulin upon the influx of tryptophan into the brain of rabbits. It was done on rabbits. It was done in mice. It's interesting that each animal has a different variant on how much it's affected, and they actually have rates of speed that they can determine that. And this is a nice article. I just want to put this up here. And what this is about is that if you eat a diet that is fairly high in tryptophan, that when they gave mice tryptophan, what happened is they developed immune cells that were more tolerant to the inflammation of the gut. And that's what they talk about, that a normal bacteria, and it's the Lactobacillus reuteri, that is activated with tryptophan. And so together, the Lactobacillus reuteri with the tryptophan-rich diet can actually reprogram the epithelial CD4 T cells into immunoregulatory T cells. So it's very interesting on that. So I thought that was pretty neat. And I'll give you one last fact, and this is pretty neat that, because a lot of people, we talk about the fact that we eat a lot of turkey, we eat a lot of food, but why is it that for Thanksgiving Day, you may have turkey, but for that morning breakfast, what are you going to have? It's going to probably be, there's a good chance that you may have some eggs. And how often do we eat eggs? I mean, say there's all these turkeys. I can't remember how many. I saw a thing yesterday. I think it's 45 million turkeys will be eaten on Thanksgiving Day. It's like, well, what about all the turkey eggs? Well, here's the thing about turkey eggs. They can cost anywhere from 15 to 20 times more cost than a chicken egg. 15 to 20 times. And the interesting thing about them is And there's a reason, of course. You know, it's supply and demand. Turkey only lays an egg, about 2 eggs a week. Chickens, 1 a day. A chicken takes up much less space than a turkey. Requires way more space. I mean, like a ton more space. But the thing is that they really contain a lot of the similar nutrients, but a turkey egg is about 1.5 times larger than a chicken egg, yet it has about 4 times the nutrients. Not only does it have 4 times the nutrients, but it has a higher level of fat, has a higher level of cholesterol. It's richer. The chefs say it tastes way better. And in fact, a lot of these like Michelin 3-star restaurants and stuff in Europe, and what they'll do on some of the things that they're famous for when they make certain dishes, they'll use turkey eggs instead of chicken eggs, and the reason is because of the fact that it's much richer. It tastes, and they say it tastes much better, but it has about twice the calories. So think of it, it's 1.5 times the size, but about twice the calories. But they say it's about 4 times the nutritional value. So I thought that was pretty cool that so you understand that. And just remember, when everybody says that it's the tryptophan, just remember it's not. It is the tryptophan in a way, but it's really the rise in the insulin. It's the overload on the digestive system, and the fact that yes, there's a slight increase of tryptophan, but interestingly, the slight increase, if you just ate the turkey by itself, you wouldn't get that increase in the tryptophan into the brain. You only get the increase in tryptophan into the brain because of the rise in insulin, and the rise in insulin is from all the other carbohydrates. It's the potatoes and the sweet potatoes or yams and the pies and everything else. So watch yourself this Thanksgiving. Remember, it's not about food. It's about family. It's about being around, getting together. It's about all the people being together. And so remember, you know, we tend to make events about food. Let's make this one about the people. Alrighty. And don't forget, we are on Saturday from 9 a.m. till 10 a.m. And we will be on this Saturday. And we have a great guest on. And I can't wait to see you then. Alrighty. Have a great day.